Good day, everyone. Today we're gonna take shell. We don't call it shell. We call it what orbiter. But before we go, you need to understand by electronic configuration. Electronic configuration is arrangement of electron into various shell, while electron configuration is arrangement of electron into various orbitals. Now, according to Bohr atomic model, Bohr proposed these to be the structure of an atom, the atomic structure. It proposed this, and from its statements, one of it is he said that electron revolve in a circular part called orbiter or shell. So this circular part from there, it means that all the circular parts here, they are shell. You don't call it shell, you call it what you have, orbiter. And mind you, whenever you're drawing it, you need to show this center here. So what you call this center is what is in the nucleus. Now we check how many shell did I have here. I have the outermost shell, which is called the valence shell. Before the outermost shell, we call it what, penultimate shell. While the one inside, we call it what you have, the inner shell, or you call it what, the core shell. Very simple. So the next one move down to, based on Bohr says that each of these shells are associated with a definite amount of energy. So therefore, the first one, N, so each of these shells are number 1, 2, 3, proposed by this is also proposed by Bohr. Each of this level, this is level 1, this is level 2, this is level 3. Further, you'll see that each of the energy level are associated with a definite amount of energy, which they denote K, L, and N. So to round it up, there's what we call suborbital or subshell. We have shell, we have subshell, or we have orbiter and we have a suborbital. Mind you, the difference between orbiter and the difference between an orbit. An orbit is just like the orbit is just like a circular part. Why the orbiter itself? The orbiter, in a simple term, is the location of an electron or a three-dimensional region around the nucleus of an atom of an element where the probability of finding an electron is maximum. So now to take the next one, based on what Bohr. So Bohr also let us to know that as energy increases, it increases with the increase in distance from the nucleus. Let me come again. Energy associated to each of these shells, it increases with the increase in distance from the nucleus. So what that implies? So the distance here is our radius. And this let us know that for each energy associated to this and this and this, it increases with increase in distance from the nucleus. So therefore, what am I going to call this? This is our first energy level, this is our second energy level, and this is our third energy level. So based on that, that let us know that therefore the first energy level is less than the second energy level, while the second energy level is less than third energy level. What's the reason? The reason being that energy associated to each energy level increases with increase in distance from the nucleus. Very simple and precise. And the last one, which I need you to know, we have subshell, from the subshell, meaning all suborbitals. A shell contains some apartments or compartments where electron can be found. So that was subshell or suborbital. And to get this, the number of orbital present in each shell is equal to the principal quantum number, meaning it's equal to this number. So what am I trying to say? N is equal to 1. I'm going to have one subshell, or I'm going to have one suborbital. So while N is equal to 2, I'll be having in the second energy level known as L shell, I'll be having how many orbital? 2 orbital. While in the third shell here, I'll be having what's going to be the number of orbital? 3. So the first orbital here is what we have here is S. Is S. Why the second? Actually, no, 2. So I'll be having 2 orbital. That's what we have here, SP. So what energy level here? We have what? S, P, and what we have a D. If I to draw the fourth shell, the first shell will be denoted as N, while the suborbitals in it will be S, P, D. Thank you very much. We're going to stop here. We'll continue in our next class.